So for today, we will have exponential function. The focus this time is on exponential equation and exponential inequality. So the most essential learning competencies are the following. Recall the properties of exponents. Distinguishes between exponential function, exponential equation, and exponential inequality. Solve exponential equation and solve exponential inequality. So we recall the different properties of exponents. We have a raised to 0 is equal to 1. Anything raised to 0 will always be equal to 1. If you have a negative exponent such as a raised to negative n, it's equal to 1 over a raised to m. If you are multiplying of the same base, we get the sum of the exponents. Finding the quotient of the same base, we get the difference of the exponents. If you have an expression with an exponent raised to another exponent, you get the product of the exponent. If you have a product raised to an exponent, you raise each factor to the exponent. And if you have a quotient raised to an exponent, you raise the numerator as well as the denominator. So in the previous lesson, we have defined an exponential equation. So again, exponential equation is an equation in which the variable is found in the exponent. So we have examples of exponential equation. 4 raised to x minus 1 equals 16. 9 raised to x squared equals 3 raised to x plus 3. 125 raised to x minus 1 is equal to 25 raised to x plus 3. And 4 raised to x times 2 raised to x squared equals 16 squared. So these are examples of exponential equation. So we have different properties. So for positive real numbers, a should not be equal to 1 and b also should not be equal to 1. And real numbers x and y, a raised to x is equal to a raised to y, for x should not be equal to 0. So again, positive real numbers a and b, a is not 1 as well as b is not 1 also. And we have real numbers x and y, a raised to x is equal to a raised to y, for x is not equal to 0. This is if and only if x is equal to y and a is equal to b. So again, we have an exponential inequality. So an exponential inequality is an inequality in one variable having a variable in the exponent. So we have the following examples. 3 raised to x plus 1 is greater than 243. 3 raised to 4x plus 1 is greater than or equal to 512. 9 raised to x is less than or equal to 27 x raised plus 1. 1/3 raised to negative x is greater than 27 raised to 2x plus 1. So we have to recall some rules for solving inequalities. So remember, if you add or subtract same real number from both sides of the inequality, the symbol is not changed. And also, if both sides of the inequality are multiplied or divided by the same positive real number, the inequality symbol still not change. However, if both sides of the inequality are multiplied or divided by the same negative real number, the inequality symbol should be changed. So when solving inequality, exponential inequality such as b raised to m less than b raised to n, the resulting direction of the inequality, m is less than n or m is greater than n, is based on whether the base is greater than 1 or less than 1. So how do we solve an exponential equation or an exponential inequality? So to solve an exponential equation or exponential inequality, we simply express each side of the equation or inequality as the power of the same base Then, we apply the different properties for exponential equation or exponential inequality. So, for example, if we have 4 raised to x minus 1 equals 16, as stated in the previous slide, so we have to make them of the same base. So we have 4 raised to x minus 1 equals 16. So we rewrite them with the same base. So 16 can be written as 4 squared. So rewrite with the same base. And then applying the property, since they have the same base already, using the property, we simply equate the exponent and solve for x. So here, since the base is already 4, based from the property, so solving x, we have x equals 3. So another example, this time you have 125 raised to x minus 1 equals 25 raised to x plus 3. Again, first step, we write them with the same base. So 125 and 25 can be written with the base of 5. So 5 raised to 3 for 125 and 5 squared for 25. Since again they have the same base already, using the property, equate the exponent. So we have 3 times x minus 1 equals 2x plus 3. Simplifying, you have distributing 3, 3x minus 3 equals distributing 2, 2x plus 6. Then solve for x. So here, x is equal to 9. Next example. So you have 9 raised to x squared equals 3 raised to x plus 3. Again, you write them with the same base. So you have 3 squared is equal to 9. So multiplying 2 to x squared, you have 2x squared. And the right side will remain the same. So we have 2x squared. Since they have the same base already, again, using the property, equate the exponent. So you have 2x squared equals x plus 3. So this time, we have an equation with the power of 2. So this is a quadratic equation. So recall, how do we solve quadratic equation? So we solve by factoring, completing the square, extracting the root, or using the quadratic formula. So for this particular case, the given quadratic equation can be solved by factoring. So you have the factors 2x minus 3 times x plus 1 equals 0. Then equating each factor to 0, we'll have x equals 3 over 2 or x equals negative 1. Okay, so this time you have 4 raised to x times 2x squared equals 16 squared. So, this one can be written as 2 raised to 2x times 2 raised to x squared equals 2 raised to 4 minus 2. Can we equate now the exponents since they have the same base? Not yet. So, what do we do? Again, recall the properties of exponents. If you are multiplying of the same base, what do we do with the exponent? We add the exponent. So, this time, this is equal to 2 raised to 2x plus x squared equals 2 raised to 4 minus 2. That's why they have now the same base. We simply equate the exponent. So, we have x squared plus 2x equals 8. Again, this is a quadratic equation and can be solved by factoring. So you have x plus 4 times x minus 2 equals 0. So we have possible values of x equals -4 or x equals 2. Okay. So, again, how do we solve an exponential equation? So, first, rewrite with the same base. Next, if they have the same base already, equate the exponent and then solve for x in the given equation. So again, it is important for you to rewrite them with the same base before equating the exponent. So next, for exponential inequality, so you are asked to solve and write the solution set in interval notation. So again, you have to put in mind if you are solving exponential inequality, if you are multiplying or dividing the inequality by a negative number, you have to reverse the inequality symbol. As well as for exponential inequality, if the base you are using is less than between 0 and 1, you have to reverse also the inequality symbol. Let me deal on that one on detail with the given example. So, the first one, so same, rewrite them with the same base, and when they have the same base already, solve the resulting inequality. So, you have 3 raised to x plus 1 is greater than 3 raised to 5, because 243 can be written as 3 raised to 5. So, they have the same base already. Equate. You have x plus 1 is greater than 5. And then, since the base that we use is 3, it's greater than 1. So, the inequality symbol is retained. So, we have x is greater than 4. In interval notation, it's 4 to infinity. Next, 2 raised to 4x plus 1 is greater than or equal to 512. So rewrite with the same base. 512 can be written as 2 to the 9th. Again, retain the inequality symbol since the base that we use is 2. So you have 4x plus 1 less than or equal to 9. Solve the inequality. So we have x is less than or equal to 2. So, from negative infinity to 2, since the inequality symbol is less than or equal to, we use bracket. Next, 9 raised to x less than or equal to 27 raised to x plus 1. Again, rewrite them with the same base. So here, 9 and 27 can be written as 3 squared and 3 cubed. And then, the base uses 3 greater than 1. So, retain the inequality symbol. So, solve the resulting inequality. So, we transpose 3x on the left side, resulting to negative x less than or equal to negative 3. Simplifying, we multiply it by negative 1. So, we multiply it or divide it by negative 1. We have to reverse the inequality symbol. So, the resulting inequality is x greater or equal to negative 3. So, writing the solution set in interval notation, you have negative 3 to positive infinity. Next is the inequality 1 over 3 raised to negative 3, rather negative x greater than 27 raised to 2x plus 1. So here, if you are to use the base 1/3, this is the first solution. So 1/3 is, so we write with the same base. So since the inequality symbol is less than 1, we have to reverse. Rather, since the base is less than 1, which is 1/3, we have to reverse the inequality symbol. So from greater than, it becomes less than. So they have the same base already. Solve the inequality. So you have negative x plus 6x greater than negative 3. Solving for x, we have x is greater than negative 3 over 5. So the solution set is from negative infinity to negative 3 over 5. So what if we decided to use the base 3? So this time, since at the start, we changed the base to 3, we will not reverse the inequality symbol. So this is just 3 raised to negative 1 times negative x greater than 3 raised to 3 times 2x plus 1. So they have the same base already. Equate the inequality. So we have x greater than 6x plus 3. Simplifying the inequality, you will have negative 5x greater than 3. So to solve, we divide it by negative 5 or multiply it by negative 1 over 5. So since we will multiply it by a negative number, you have to reverse the inequality symbol. So we have the same solution. Either we use a base of 3 or a base of 1/3. So again, recall what is an exponential equation. Can you give an example? As well as an exponential inequality?